Hello everyone, welcome to my YouTube channel Spot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about decoder and the RTL design implementation of 1:2 decoder and 2:4 decoder by using System Verilog constructs. Now if I talk about decoder, so basically it's a combination circuit which converts binary input data into the distinct output signals, and it activates one of the output line at a time based on the input binary values. Basically, it consists of n inputs and 2 to the power n output. That means if I have one input, so 2 to the power 1, that is 2 outputs, and it will act as a 1:2 decoder. If I have 2 inputs, so 2 to the power 2, that is equal to 4. That means 4 outputs, and so it acts as a 2:4 decoder. If I have 3 inputs, so 2 to the power 3, that is 8 outputs. So then it will act as a 3:8 decoder. Okay. And basically it is used to generate either active high or active low output. In practical applications, decoders are used to select one of the memory or input output devices at a time. Okay, and to enable the expansion of a decoder can have either active high enable or active low enable. Now based on binary input values, we are having different types of decoders. That is 1:2 decoder, 2:4 decoder, 3:8 decoder, and 4:16 decoder. Now if I talk about working and functionality of 1:2 decoder, so it has one bit of select line, that is the input, and enable, and 2 outputs. As I told you, if select line is if 1 input, so 2 to the power 1, that is 2 outputs. So here for active high enable, if input is 0, then Y0 will be active. If input select is high, then Y1 will be active. You can see the truth table for active high enable. If select is 0, the input select is 0, then Y0 is high, and if select is 1, then Y1 is high. Okay, based on this truth table, we are having boolean expression for Y0 and Y1. So if consider if select is 0, so due to this not, it will be high. So enable is already high, so 1 and 1, my Y0 is 1. That time Y1 will be low because select is 0. So and truth table says that if any input is 0, then output is 0. So Y1 will be 0. Okay, when select is high, so that time due to this not, select will become 0. So for Y0, that time will be low and Y1 will be high. Okay, now if I talk about working and functionality of 2:4 decoder, so name suggests it has 2 inputs and active high enable line. If 2 inputs are there, then obviously 4 outputs will be there. So Y0, Y1, Y2 and Y3. Okay, for active high enable, you can see the truth table. If S1 and S0 both are 0, then only Y0 will be high, active. If S1 is 0 and S0 is high, then Y1 will be active. If S1 is high and S0 is low, then Y2 will be active. And if S1 is and S0 both are high, then Y3 will be active. Okay, so based on this truth table, we are having boolean expressions for output Y0, Y1, Y2 and Y3. You can see if S0 and S1 both are low, so then Y0 will be active through this boolean expression, enable and not of S1 and not of S0. For S0 is equal to high and S1 is equal to 0, Y1 will be active. Y1 will be active for this boolean expression, enable and S1 bar and S0. Similar with Y2 and Y3. Now let's jump for the RTL design implementation of 1:2 decoder and 2:4 decoder by using SystemVerilog constructs. Here you can see I have already written a SystemVerilog code for the RTL design implementation of 1:2 decoder. So let's go through the code. Here my tick time scale is 1 nanosecond divided by 1 ps. My module name is decoder 122, and we are having input S0 and enable, and output Y0 and Y1. Now inside the combinational procedural block, for active high enable, I have used here a case statement. Inside the case statement S0, if my S0 is low, then I have assigned high to the output y0 and low to the output y1. If s0 is high, then I have assigned 1 to the output y1 and 0 to the output y0. Okay, and if there is and if the enable is low, then y1 and y0 both are low. Okay, and execute this code, then it has given me the schematic. Here you can see enable is going for output y0 and y1 and this s0. Okay, so based on the s0, if s0 is 0, then y0 will be active, and if s0 is high, then y1 will be active. Okay, even to perform the operation of 1:2 decoder, I have used here assign construct. So we'll check this also. I will comment this logic. Okay, and I will also comment this assign statement. As I have explained you the boolean expressions for output y0 and y1. Okay, so if there is enable and not of s0, then y0 will be active, and if enable and s0, then y1 will be active. Okay, if I save this and reload, then it will give me the schematic in the form of boolean expressions. Okay, here you can see that enable and s0. If enable is high and s0 is low, then y0 will be active. If enable and s0 both are high, then y1 will be active. Okay, now to verify this a decoder 1:2 decoder, I have written simple TB code, System Verilog. You can see my module name is TB for decoder 1 to 2. Same inputs, that is 1 bit of s0 input enable and two single bit of outputs, that is y0 and y1. And this is the instantiation. Here I have used wildcard operator. It will automatically take instantiation of all the signals. Okay, now inside the initial begin, I have given initially I have checked for enable is equal to low. Expected is y1 and y0 and y1 both should be low. And when enable is high, then I have given s0 is s0 value and s0 value, that is 0 and 1, and taking. Now if I click on this run simulation, as I have already run this, I will just click on this relaunch simulation, so it will give me the waveform. Okay, and we'll so here you can see when my enable is low, that time although s0 is low and high, you can see y0 and y1 are low. Okay, because here we are checking for active high enable. So when enable is high, here you can see when enable is high and my s0 is low, so as per the truth table y0 is high. Okay, and when s0 is high, so y1 is here high. So means at a time either one output is high. Okay, so this is the working and functionality of 1:2 decoder. Now let's jump for the RTL design implementation of 2:4 decoder. You can see I have already written and System Verilog code for the RTL design implementation of 2:4 decoder. So let's go through the code. Here my tick time scale is 1 nanosecond divided by 1 ps, and my module name is decoder 2 to the 4, and we are having inputs enable for active high enable and two inputs, that is s0 and s1. If there is two inputs, then 2 to the power 4 or 2 to the power 2, that is 4 outputs. We are having 4 outputs, y0, y1, y2 and y3. Now inside the combinational procedural block for active high enable, I have used here a case statement for input s1 and s0. If s1 and s0 both are low, then y0 will be active. So for that I have assigned 1 to the output y0 and 0 to the other outputs, that is y3, y2 and y1. For s1 0 and s0 is high, I have assigned 1 to the output y1 and 0 to the other output y0, y2 and y3. If s1 is high and s0 is low, then y2 will be active. So for that I have assigned 1 to the output y2 and 0 to the remaining output y0, y1 and y3. As we are using combinational procedural block, so for each case statement we need to provide inputs for every possible outputs. If we do not, then it will generate unintentional latches. Okay. And for enable low, for input enable low, y0, y3, y1, y2 and y3 both are low. Okay. Now if I click on this schematic, so it has given me this type of schematic. Here you can see enable, for enable, and based on S0 and S1, any one of the output will be high at a time. Okay. We can implement the same logic by using simple assign construct also. So here you can see below I have implemented, but first I will comment this logic, and I will uncomment this assign constructs, which is used here to implement the 2:4 decoder operation. So here you can see I have assigned enable and not of S1 and not of S0 to the output Y0, enable and not of S1 and S0 to the output Y1, enable and S1 and not of S0 to the output Y2, and enable and S1 and S0 to the output Y3. If I save this and if I reload, then it will give me the schematic, gate level schematic. You can see Y0 is assigned with and of S0 and the output of and between enable and not of S1. Similarly, Y1 is assigned with and of enable and not of S0 and the S0. And now to verify this 2:4 decoder, I have written simple TB code. Here you can see the tick time scale is 1ns divided by 1 ps. My module name is TB for decoder 2:4. We are having same inputs, that is enable, S0 and S1, and 4 output Y0, Y1, Y2 and Y3. This is the instantiation decoder 2:4 and decoder and dot star. Okay. And inside the initial begin, I have given combinations of S0 and S1 for active high enable. Okay. Now if I click on this run simulation, so as I have already run this, we'll check the waveform. Okay. Here you can see for active high enable, when my S0 and S1 both are low, so Y0 is high at a time. Okay. At that time you can see Y1, Y2 and Y3 are low. That means Y0 1 is high. When S0 is 0 and S1 is when S0 is high and S1 is low, so you can see Y1 is high, remaining output, that is Y0, Y2 and Y3 are low. When S0 is low and S1 is high, then Y2 is high. And when S0 and S1 both are high, then Y3 is high. Okay. So this is how 2:4 decoder works. So basically in this video we discussed decoder and the working and functionality of 2:4 decoder and 1:2 decoder. Even we saw the Boolean expressions of both 1:2 decoder and 2:4 decoder, and we discussed RTL design implementation of 1:2 decoder and 2:4 decoder by using SystemVerilog constructs. So here I will stop the video. In next part we'll discuss RTL design implementation of 3:8 decoder and 4:16 decoder by using SystemVerilog constructs. Thank you so much. If you are new to this YouTube channel, then please subscribe to my YouTube channel, and if you are watching this video, then please click on the like button.